Welcome back. We are looking at using work energy theorem in case of chain strings, ropes which have mass. And I took that linear density as lambda, if you recall. This is what I did. I would just go back to that. Likewise. So this is lying on this. Now this is somewhere here. I took this potential energy as 0. Now this is beta. But if you want to know from here what is this, consider a small elemental along the dx. Okay? At a distance x. So that what is the height here? X sin beta. What is the mass of that element? Lambda dx. Okay? And what is the potential energy of this element? M G H. I didn't do it purposely in the other class, expecting you to x dx. Now potential energy means, so this, if I take s, this is 0 to s. So lambda g sin beta x squared by 2, that is s squared by 2. This is how I did it. It is linear, therefore there is no issue. And anything above we took it as positive, anything below we took it as negative. And then once the whole chain is just about to hang, because the last link leaves that surface, then we found out the whole thing is negative. We got the work done and equated. There is no friction here. That is what I want you to understand. Okay? Now, suppose I take like this, say the entire length L, that is the length of the inclined surface also, and angle is of course beta, and if the whole thing falls down, you would like to know what is the velocity of the chain. That is fine, because what am I interested in here? This PE is 0. PA here is minus mg. I need not have to do this every time, but this is what PE final. What is PE initial? We just did this. From here, what is it we got? mg sin beta L squared by 2. We have just worked out. If you see that, okay? I think it is not mg L squared. Lambda g L squared. The same thing here also. Be careful. It is the dimensional problem. Lambda the L square by 2, but lambda L is nothing but m. So you are free to put that. That's it, we will see it later on. This is plus. So what is the work done by gravity? Initial minus final. So lambda g sin beta L squared by 2 minus of minus. Likewise, this is the work done by gravity. What has happened to, supposing if friction is present here, so the whole thing is a kinetic. So let us say it is at a distance x, okay? The frictional force is, now what is frictional force here? Frictional force is mu mg mu n actually. Okay? N. But n, how do you get it? How do you get that? You know, this is very crucial. Let us now look at this. This is dn. What? So dfk is mu dn, and dn is this mass is dn. Therefore, this is the force, and this is dmg cos beta. So you have mu dmg cos beta. That is the frictional force. Okay? On this elemental mass. Okay? But what is happening here is, on this entire thing, that is acting, the friction. So if I integrate it, I will get the total frictional force. You know, it's only dm, therefore you will get whatever dm is lambda dx. Okay? So if x is lying, your fk will be mu lambda g cos beta x upwards. If it moves downwards by dx, so those both are opposite. You get the point? Both are opposite. So the work done is minus mu lambda g cos beta x dx. Okay? But the thing is, dx, I told you the other day, x is decreasing, therefore dx is negative. So you will get this as positive. Now the next is fairly simple. W by friction mu lambda g cos beta. Now you start with L and 0, so you will get a negative sign. That is work done by friction. See how am I putting it? Alright. So the work done by friction is minus mu lambda g L square cos beta by 2. Now, problem is with you. You can directly solve it. The total work done by these two forces is equal to change in kinetic energy. So sum of these two, this plus this, lambda g L squared by 2, and this is minus mu lambda g L squared by 2 cos beta is half lambda L mass v square. I think the rest you can easily do it. Lambda L gets cancelled everywhere. Incidentally, it also gets cancelled everywhere. So what are you left with? GL into 1 plus sin beta minus mu cos beta under root is your bit. Now this is very interesting. You can very clearly see. That's how you get the friction is involved and mu is constant. This is important. Okay? In case mu is a variable, they will give you that. So you can put mu is equal to say kx or kx square or these things. Hope you are able to understand how am I working on these chains. Now look, I go little deep into the same chain problems. Suppose I am taking here it is. radius is R. Now you have to follow these things carefully. This is all a smooth surface. Therefore, by the time the last link leaves the surface, the smooth surface, what is the velocity of it? As before, I take P0, therefore it is negative. What is this? Minus lambda Lm G L by 2. That is the final potential energy. Now, initial potential energy you have to find out. Let us say this is theta, this is d theta, therefore length is r d theta, the mass is lambda r d theta. What is the height of it? Now r sine theta. R sine theta. So therefore, the potential energy of this elemental mass is dm, that is all this, G, and H is R sine theta. Now that is very, very important for you. I took 0 here, therefore above is positive, below is negative, and then if I integrate this, what am I getting? Potential energy initial, lambda r square g is common. Then you have integral sine theta d theta. This is important. Integral sine theta is minus cos theta. Now the limits part. Now I do not know from where to where. I am taking from alpha to beta. I am just telling you. I want to generalize this. I just want you to see, suppose that saying this is alpha, that is beta. So this is the chain that is present here. That is the chain present there. So I take alpha to beta. Okay? That is fine. Now, in this case, what is this? 0. Alpha is 0. Beta is pi by 2. But we will have this as a standard expression for us. I am erasing this part of it. Now, what do you write? Lambda r square g. Reverse the sign and reverse the. So cos of alpha minus cos of beta. This is the standard expressions that we are going to have. Now, very important, I am telling you, every time this kind of a curvilinear surface is given, we can directly take in this fashion and find out what we want to do. P final is minus lambda L square G. But what is L? L is, if I take, I have shown you here, what is this length? I mean, angle beta minus alpha. So, R into beta minus alpha is the length. So, L is R into beta minus alpha. In this case, what is beta? Pi by 2. What is alpha? 0. So, length is taken like this. Okay? I am putting in a very, very general fashion. Minus lambda g by 2 r square beta minus alpha square. Now, initial minus final. So, minus of minus, it becomes plus. Why am I taking initial PE minus final PE? Work done by gravitational force is equal to what? is a conservative force, right? Negative of change in potential energy. Negative of change means final minus initial. Therefore, I am taking minus sign inside and standardly I am taking initial minus final PE as the work done by conservative. It's always true even in the case of spring. So, what do you get? Work done by gravity plus lambda g r square by 2. All this is equal to half lambda mass I have to put r into length. This is mass v square. Now don't write it as by v square. V square. So as before, lambda r by 2 2 and I'm taking. So 2gr or rather gr into 2 cos alpha minus 2 cos beta dr plus right. This is how you have to. I have taken the most general expression in the present problem. In the present problem, what is this? You never forget to remember this. Cos theta limits rather minus cos theta. This is your potential energy. And now alpha is 0, beta is pi by 2. So cos 0, 1, this is 0, 1, and beta minus alpha, pi by 2 whole square, and this is pi by 2. That is how you have to simplify and get your answer for your velocity as the whole chain leaves. Hope this is clear to you. Okay? Now, now you see. Suppose if I take like this, what is the total length? Pi r. So what is alpha? 0. 0 to what is beta? Pi. That's all you have to do there. How? Half pi r lambda half m v square is initial plus phi minus of phi. What is this? Final potential energy minus lambda pi r m g l by 2. So this plus this, but here the limits will be 0 to pi. Or pi to 0, 1 minus of cos pi is minus 1, so 2 you will get. So 2 lambda r square g plus lambda r square g pi square by 2. This is the equation that you have, and obtain what is your value simply putting alpha and the other one, okay, the beta values. Is this clear to you? Let them give full, part, half. This is the methodology. Now you see what I do. For example, this is here. It is allowed to fall. By the time the last link leaves, there is no negative sign, remember. What is the same question? Now, they didn't give anything. So, I go with this is L, so minus lambda, this is final potential energy and initial. How do you get this? How do you get that? Yeah. Because you have to take alpha. What is this angle? If this is R, this is L, this angle is L by R. Sector angle, L by R. Okay? And what is this angle? Which is alpha is pi by 2 minus L by R. I hope you understood this. So, your alpha is pi by 2 minus L by R. Alpha is pi by 2 minus L by R. And beta is pi by 2. So, directly obtain what is the initial potential energy. How do you get that? Now, I told you it's equal to lambda r square g. Now, you have alpha to beta. If you reverse, you get cos alpha minus cos beta. Lambda r square g cos of pi by 2 minus L by R minus cos pi by 2, cos 90, 0. So, lambda r square g sin L by R. This is initial potential energy. And so, this is the final. If you want, you can directly find out final. So, this plus this is equal to lambda r square g plus lambda L square. G by 2 is half L lambda B square. Likewise, how do you write L is equal to R theta? So, okay. Now you find out what is. If you wish, you convert the whole thing into R everywhere, or convert everywhere into L. Okay? So likewise, you will get your answer V. That is fine. There is no problem with regard to that. Now what we do, supposing I will give a bigger picture. Suppose like this. So it has come to what angle do we take? Let us say it has fallen by theta. Theta we are already using it, don't get confused. I took alpha, beta, theta, we take gamma. And this is here. Now, if it moves by x, what is the velocity here? It's not falling down, just displaced by x. What is the velocity now? If I ask you like this, what do? What is this angle? Because you take it as gamma, but this is x. R gamma is x. R gamma is x. Gamma is x by r. And this is L by R. So, at this instant, my final potential energy. At this instant, alpha is pi by 2 minus L by R minus x by R. And beta, what is beta? Till this point. This is beta. Beta is, you remember, this is the base value we are taking, 0, initial length, beginning of that alpha, at the end beta. So pi by 2 minus x by r. So substitute in this. Initial you already have. What is initial potential energy? This one. Lambda r square g sine L by r initial. Final is also positive, remember. So lambda r square g cos of pi by 2. That is sine of cos beta minus cos beta is all this. So sine x by r. So you have initial potential energy, your final potential energy, this minus this. So lambda r square g sine of L by r is minus all this. So minus means this becomes plus. Sine x by r minus sine of this is changing. What is happening to all this? L lambda v square. Okay? Got it. Now, this is how you get it. So you divide what are all the factors you have. That is L by R. You try to look at the way you convert this. So lambda gets cancelled. 2 it becomes this one, it becomes L if you remove all this. Interesting. You got it like this. This is the velocity because v square I captured. Now Sometimes they may further probe you in this. How? As it is about to start, what is the acceleration? Supposing this. How do you get acceleration here? A is equal to V dv by dx or V dv by d theta. What I do, L by R is equal to theta. Okay? L by not dv dv by R d theta. Because R d theta is that length part there. If I take L by R as theta, what are you getting? 2 R square by G. L, of course, I can write it as R theta here. So this becomes sin theta sin x by R. All this is V square. So you differentiate with respect to theta. I think this is constant. You can retain it as it is. I have no. This theta, you see, if it moves by x, let us say this is theta, so x. So you have x by r is equal to theta. Because L by r gives the total length. But what is that movement that you are interested? So x is the movement. It is going like this. So by how much? So I get x by r is equal to theta. So what do I write here? This is as before sine of L by r plus sin theta minus sin theta plus L by R. Now this is V square. Because theta is my variable. If I take with the L, it remains constant. So I am not justified in taking it. Okay? Now, so what do you do? Differentiate with respect to theta. What do you get? 2 R square G by L. This is constant 0. This is cos theta. This is minus of cos theta plus L by R is equal to 2V dV by d theta. V square 2V with respect to theta dV by theta. So 1R you take on to this side. So the whole thing becomes A. So I can write it as A. But remember, by the time the chain comes somewhere here, it possesses two types of accelerations. Remember, there is a centripetal acceleration also, you can't ignore. So, when the chain is just about to start, what is the acceleration? When it is just about to start, your theta becomes 0. So, A is equal to 2 gets cancelled. G R by L 0. 1 minus cos of L by R. This is the acceleration. This way also they can ask questions. I hope there is no confusion here. I will try to explain this point to you in case of any problem. What I do, look, I am saying this one and it moves by x. So this is x. Let me take theta. So x is equal to r theta. I hope you are understanding. And then I am taking a to b, v dv by dx. But dx is r d theta. So in this sense I am writing x is equal to r theta. Well, this is clear to you. So the path need not actually come out of the surface. Even if it is slightly displaced, you can still find out what is the acceleration there. I hope this is clear to you. Okay? Now, I think we have discussed quite a number of cases as far as the gravitational potential energy is concerned, and we also included a bit of friction here. So chain problems we have done. The general, sometimes they'll ask you questions like this. I am dropping a body. It should have, suppose height is h. It should have struck with v, which is equal to under root gh. But it strikes with only, say, v by x, v by 2, v by 3, v by 4, x is greater than 1. Because of the resistance offered by the fluid, that is atmosphere. What is the work done by the viscous force due to air? So here, work done by gravity, work done by viscous force is equal to half mv square. This is the thing. What is work done by gravity? mgh. I don't know what is work done by viscosity. Half m. V square means what? It is striking only with the v by 2, v by 3, v by 4, something like that. So the work done by viscous forces is half m by x square, but v square is 2gh minus mgh. So what do you get? 2 gets cancelled. Or mgh by. It is bound to be negative because this is a force of resistance. So if x is equal to 2, this becomes 4. And this becomes minus 3. So minus 3/4 of mgh. That is how you find out the work done by the viscous force. Any other force that is generally present over there. Okay? There could be, of course, many more cases of gravity. I will discuss as and when the situation arises. I'll have to now go to combination of spring, gravity and friction, all this. Okay, thank you.